Welcome back to the channel. In today's video, we are going to talk about data partitioning and how it can help you scale your database efficiently. Data partitioning is an essential concept for managing large datasets and improving systems performance, especially as your application grows. Let's explore what data partition is, the different types, and how you can use it to scale your database effectively. So let's jump right in. First, what is partitioning? Data partitioning is the process of dividing a large dataset into smaller, more manageable parts called partitions. Each partition can be stored and accessed independently, which helps improve the performance and scalability of your database. Think of a partitioning like splitting a big library into different sections by genre. Instead of having the search through thousands of books, you can go directly to the relevant section, making retriever much faster. Okay, so why we use data partitioning? Data partitioning is a process. We use data partitioning for several reasons. One of them is to improve query performance. By dividing the data into smaller partitions, query performance is improved since database engine only needs to search through a subset of data rather than the entire dataset. For instance, if you are sorting or storing data for millions of customers, partitioning by region allows queries for specific areas to access only relevant partition, leading to significant faster results. The second thing, which will be ease of maintenance and scalability. Partitioning makes your database more scalable as your data grows. Instead of overloading a single large database, you can add a new partitions. It also helps in maintaining your system since each partition can be backed up or restored independently. For example, you might store data in monthly partitions. If you need to achieve old data, you can simply remove older partitions without affecting the rest of the system. Okay, right now we need to talk about the types of partitioning, and let's start with the range partitioning. Range partitioning divides database into specific range of values, such as dates or numeric IDs. Each partition stores data that falls with a certain range. For instance, if you are managing customer orders, you could use order date as the partition key, storing orders in monthly or yearly partitions. This makes it easier to query specific time periods. The second thing, which is hash partitioning. Hash partitioning involves applying a hash function to a key field to determine which partition the data should go to. This method helps distribute data evenly across all partitions, reducing the chances of hotspots. If you are storing user profiles, you can use user ID as the hash key. The hash function will then distribute these profile evenly, ensuring that no single partition is overloaded. And we have list partitioning. List partitioning allows you to specify a list of values that each partition will store. It's useful when data naturally falls into a few distinct categories. For example, you could partition customer data by country. Each partition could store customers from a specific country, which can make queries like find all customers in Germany more efficiently. Um, and we have composite partitioning. Composite partitioning combines two or more partition methods, such as range and hash. This approach provides flexibility and helps in balancing the data load effectively. You might use range partitioning on a date field, and then hash partitioning on user ID within each range to ensure data distributed evenly while still being logically grouped by time. Okay, let's talk about some challenges of data partitioning. And first thing we will talk about, which will be the complexity. Okay, I forgot to put it here, which is the complexity in querying. Partitioning can introduce complexity in querying execution if data needed for a query is spread across multiple partitions. The database must aggregate results from each partition, which can increase query time. For instance, a report that needs to access customer orders from multiple regions might require the database to scan several partitions, leading to slower performance compared to accessing a single partition. Second, we have hotspots. If the partition key is not chosen wisely, you can end up with hotspots where some partitions store significantly more data than others. This can lead to performance bottlenecks. For example, using a data field as partition key in an application with mostly effective with most activity happening in recent month could overload recent partitions, while older partitions remain largely unused. The second we want to talk about some best practices for data partitioning. The first thing is to choose the right partition key. Choosing the right partition key is crucial. It should ensure an even distribution of data and avoid creating any hotspots. Consider both read and write access patterns to determine the most effective partition key. The second thing is to monitor and adjust regularly. Use monitoring tools to keep track of partition sizes and performance metrics. Adjust partitioning schemas as your data patterns evolve to maintain optimal performance. And third, which is to combine partition strategies if needed. In some cases, combining partitioning strategies can be beneficial. For instances, ranges partitioning combined with hashing partitioning can help balance the data while keeping it logically organized. So, to wrap up, the data partitioning is a powerful tool for the scaling your database, improving query performance, and managing large datasets effectively and efficiently. Whether you use range, hash, list, or composite partitioning, it's important to plan carefully and monitor performance regularly to get the most out of your partitioning strategy. If you found this video helpful, make sure to subscribe and hit the notification bell so you never miss a video. And yeah, and see you in next video.